Hello everyone, today we are going to learn how to debug our Gpio program in Keil Microvision 5. So this is basically a debug session where you will learn how to use the debugger and how to debug your program in running in the microcontroller. The microcontroller I am using is STM32 F103. If you haven't watched my previous tutorial, just go back on the bare metal Gpio LED toggling tutorial where I have created this code and I have from scratch, and I have told you how to come up with this code. This is the part 2 series of the previous tutorial, and we are going to learn how to debug our code. Let's see where the board is, and this is my board, if you can see. Okay, let me just a little bit focus. Okay, so this is my board, and this is the green LED is a power LED, and the PC13 LED is a red LED which is connected, and here you can see the crystal is 8 megahertz. So let's get back to the Keil Microvision and just configure some of your options for the here you need to change the crystal value from 12 to 8, and after that if you required hex file, you can check this checkbox, and if on the debug session you need to connect select the ST-Link which I am using, the ST-Link debugger, and I'm using ST-Link dongle to debug this session, and go to the settings, and just if you had connected your dongle into the computer, you will see this unit available here, which in my case is version 2 of ST-Link, and in the flash download tab you need to check reset and run, so that it automatically reset the microcontroller once it flashed. And if you select this medium density flash, because we are not using 128K of flash size, we need to change this value from 2 to 1. So after setting this, press OK and press OK here again. After that select the debug menu and stop debug session. You can also choose to press Control F5 to start this debug session. It will prompt a message that you are running the code limit of 32K. This is because we are using a free version of Microvision 5, so we are totally okay with it. Just press OK button, and it will open a debug perspective for you. Here you will see some of your registers. You need to not need these registers for now. All we are concerned is about our registers that we had modified, and these registers are related to the GPIO. So we need to open up the GPIO registers. Just go to the peripheral menu, and in the GPIO section select GPIO C, because that's the GPIO that we are going to toggle. And because we had used the 13th bit, and we need to scroll down onto PC13, here you will see that it is a floating input. This is because when our controller reset power on, it will automatically floating input all the GPIOs. So we need to step over. We can use the F11 button to step over, or we can press this button on the toolbar menu, and it will select over clock, and if you step over again, it will make it analog input. This is because, just make sure that our PC13 is analog input. This is because we had reset the values, and all the values are for the PC13 is 0. So it will make it analog input. But if we toggle the 21st bit into 1, it will make them GP output push-pull manner. So here you can see now our PC13 is properly configured in GP general purpose output push-pull manner. So we had properly configured this in general purpose push-pull manner. So if you go to your microcontroller, you will see the LED is on. It means that PC13 is in this state is 0. So here you can see the ODR register is 0. It means our PC13 bit is 0. This is because our LED is connected in common anode mode. That's why when we write 0 to the pin, it will make LED to turn on, and if we write a 1 to the LED, it will make the LED to turn on or turn off. So if we step over again, this will toggle the LED, and you will see that it will go to 1, and the LED on the board is now off. If I just minimize it, and so that you may see this side by side, it will look like something this. And here you can see when I step onto it, the LED is the port 13 is written to 0, and when it written back to 1, that is all LED is off and on, off and on. So that's the way to debug our program in Keil Microvision 5, and once you are done, you can just totally stop this session again by pressing the same button or the same key, which is the control plus F5. So that was all about the debugging session in the Keil Microvision. This is very important to know how to debug a program, because this is a very complex 32-bit microcontroller, and whenever you are dealing with a complex architecture, you always need some strong and powerful debugging tool to debug your code, so that you not get stuck somewhere, and you may have a clue to what is going on underneath the registers, and either the values of the register is being changed accordingly or not. So that's all for today's tutorial. In today's tutorial, we summarize about the debug session, and don't forget to watch the previous video, and don't forget to subscribe, and don't forget to comment if you have any query, or either you like it or not, or what you want to see more in the upcoming videos. And please stay tuned, and this series is going to be the STM32 programming bare metal from scratch. So stay tuned, and thank you so much.